Hello and welcome to this brief podcast. What's up in the night sky? A friend candidly reminded me that I've not recorded one of these for a while. Very sorry about that. It's been kind of hectic, what with the modules and everything else I'm doing. But I thought I'd snatch a quick 5 minutes just to quickly look over some of the highlights in the night sky. Obviously, it's getting darker later now, so we're starting to lose that as we're getting closer and closer into summer. But still a couple of delights to see. If we look over then to the western horizon, this is about just gone 7 o'clock in the evening. You see Venus is there in the constellation of Pisces, and it's an unmistakable object to see in the night sky. In fact, it's one of the first things that comes visible. It's an early evening object, and we're slowly starting to lose it now into the sun as we move away. So what does appear as a evening object will soon become a morning object. So there's Venus there, and if you can get a small telescope onto that, you might be able to make out the small crescent phase on there. Venus as a planet is actually the hottest planet in the solar system. Believe it or not, it's about the size of the Earth. Temperature of about roughly 450, 460 degrees Celsius. If you were to go there, you would almost certainly be crushed immediately under the pressure. And if you took a metal pot and put it on the floor, it would melt. And it's one of the planets which is largely, for that reason, unexplored. And it rains sulfuric acid as well, which doesn't help. They are actually trying to find a more robust kind of spacecraft to send there. After repeat upon repeat upon repeat, I think we managed to send something there, and it sent one picture back, and then that was it before it died. So probably of all the terrestrial planets, that's a planet that actually has a surface on it we can land on. Venus is the one we've not really been able to explore, and one of those which we have got no ambitions at all whatsoever of trying to colonize one day. I mean, we just wouldn't last. The atmosphere's it would cost an awful lot of money to make and a lot of time to make it habitable, Venus. And even so, it's probably not much on there after the millennia of punishment that the surface has had for us. But one of those surfaces, unfortunately, one of those planets, unfortunately, we can observe safely from the outside, but probably best not going inside to take any closer look. Venus, beyond Venus, so is Mars, and Mars is obviously a lot in the news now with SpaceX. He wants to send a colony there to live there in the next decade or two. As a planet, it's a bit more hospitable than Venus, although the atmosphere is predominantly CO2. We couldn't breathe it. It's toxic to us and also very cold. I think that the maximum temperature it would hit is about 15 degrees Celsius during the day, and it can plummet considerably below that at night. So we'd certainly freeze to death if we couldn't get somewhere warm. It's a very small planet. It's probably about half the size of Earth. But if you can get a telescope on it, it's interesting to see because you can see the different dark areas on there. And if you get a webcam on, and take a nice, couple of frames of that, then you'll be able to see that if you stacked it in Registax using the tutorials I've shown you in Space Cadets. But it's one of those planets where there's a lot of romance, and we've got, about the planet. There's a few rovers going around there sampling soil at the moment, and it's just one of these where we'd like to find life on it, or at least some sort of proof or evidence that there has been life. But we're planning a number of things with Mars to make it a habitable planet. So that'll be interesting to see how that materialises. But as I say, as a planet itself, it's quite elusive to see it because it has to be quite close up to us to see any detail. I tried myself a couple of I think a month or so ago, and I couldn't really resolve too much on there. So there it is. Uranus is just below it, and that will need a telescope to see that. This is a big ball of gas there, and it's one of the remoter planets in the solar system. We're not going to see any detail on the planet. You'll just literally see it as a star-like object. But it's there. Ceres is up there too. That is a asteroid. That's the largest asteroid in the solar system, I believe. It accounts for about a third of the mass of all the chunks of rocks. In fact, it's even spherical in shape, pretty much. So And again, that's a telescope object. So those are the planets that are available down there for us to see. And if we just come across to remind ourselves of Orion, there it is. It's nicely in the southern part of the sky now. And there you've got the main sort of bow tie shape. Those Betelgeuse I discussed earlier on up there. And down below there you've got Sirius as the brightest star in the night sky. And up here you've obviously got the belt of Orion coming down to the sword of Orion. And just before we go there, I mean, I'll just quickly mention about Betelgeuse. Betelgeuse is a bit like how our sun will be when it's old and ready to die. It's swollen up like a big red ball of gas now, and it's blown off its outer layers, and it will leave behind something like a planetary nebula, just like a ring of gas. If you were to import Betelgeuse into the solar system, it would swallow up every single planet up to the orbit of about Mars. It is that large, and yes, that's indicative of what our sun's going to do in about 5 billion years, 4 billion years or so. It's going to swell up like that as well when it uses up all its hydrogen supply, and that'll be how it goes. Obviously, we will be consumed by the sun in time. So never mind trying to colonise Mars, maybe we should be looking to colonise elsewhere, but then we've got about another 5 billion years to do so. And it's worth noting with our sun, it shines by converting hydrogen to helium. If you watch the solar module in there, it will go through that, and that's how the sun shines. And of course it burns about 15 million tonnes of hydrogen per second, which is an awful lot to us, but not a lot when you consider the size of the sun. So that's Betelgeuse in comparison to our star. If we come all the way down, there's the belt, and if we come down through the sword of Orion, let's see if I can go in a little bit. And you've got the celebrated M42 Nebula, the Great Orion Nebula there, and that is probably one of the hottest targets of any amateur astronomer, myself included. I mean, I'm trying to gather enough data to have a nice, decent image that I can showcase at home, and I've not got a bad one, but I can do better. Despite being bright, it's one of the hardest things to photograph as well. But it's a beautiful nebula, and what it is, it's the leftovers of a star that's blowing up, left a lot of gas behind. And what's happening there is you've got a lot of stars in the nebula that are now trying to form, and this is the famous nebula that we all sort of remember. Some have called it the fish, some have called it the bat. You've got a very, which I don't think you see it in there, but you've got a sort of a square of stars, and they're called the trapezium, that lights up all these, that lights up the nebula as a whole. So yeah, it's a beautiful one to see, and you can see it's moving pretty quickly as we're looking at it, and that's because it's simulating the rotation of the Earth. And of course, if that was in a circle, which is our field of view, we would soon be losing it. But I mean, even with a small telescope, we can see that as a black and white object, and the reason for it's in black and white is because our eyes aren't sensitive enough to the colour. And not only that, but when our eyes have dilated, the light tends to fall on the rods of our eyes as opposed to the cones. The cones give us colour and the rods give us black and white. And you need to use, as such, you need to use averted vision to see it properly. If you find it hard to do that, then just simply tap the edge of the telescope tube with a pencil, preferably with a rubber on the end, and you shall see it. It's a beautiful object. It can be seen in binoculars, small telescope, and amateur astronomers like myself are constantly trying to get a nice, decent image of it. It is beautiful. And how can we come and talk about Orion and the Great Nebula without talking about the Horsehead Nebula? Well, that's down here, and not far from the star Ornithak. So if we come down to the star Ornithak, we can see some red nebulosity there. That is an elusively difficult object to get in a telescope. It's without very dark conditions, you know, it's hard to photograph. But again, there it is. It's a very faint nebula, and it's called the Horsehead, obviously, because you got the structure of the horse there in the nebula, and that's another very beautiful object in Orion, and well worth, you know, if you've got the equipment to see if you can capture that. You can use the star Ornithak as your guide to getting it a bit further south to the west slightly of that, and there it is. So Orion really is an interesting constellation as a whole, and if you come back, you can see Orion the Hunter, and what Orion's doing is, there he is, there's his body, his left arm's extended, his bow, And there he is, and he's got his hands up there and he's waving his weapon ready to throw. One of the few constellations in the night sky that does actually look like what it's supposed to be. Can't really discuss all this any further without coming to look at the Pleiades. Here we are, that's the Seven Sisters, and that's a beautiful binocular object. If we zoom in a bit further, it's called M45 or Messier 45, named after the Charles Messier, comet hunter who catalogued them, and this was the 45th object in the night sky that he entered. And as you can see here, it's a nice little cluster of young stars. They've blown away the nebulosity. The nebulosity you're seeing there isn't actually part of the cluster, believe it or not. It's actually something else. But these are nice young white stars here that are, literally just a few million years old at max. And that used to be a good eye test in the ancient times. Some legions used to use it to get their potential soldiers to count how many stars they could see in that before they'd let them into the army. And in some cases it was a qualification before they'd become a bowman, is to see how many stars you can see in that. With my glasses I think I could just about manage these. Beyond that though it becomes quite a challenge. But then don't forget, in those days they had dark skies as well. So again, that's a great object to have a go at with a pair of binoculars if you so can. And yeah, there's one thing about the winter sky is, it's well, it's spring now, but it's these whereby there's so much to see, and because it's being colder, the water vapor, which causes the problems with observing in the summer, gets evaporated out usually, and gives us clearer skies. Fortunately, this year it's not been the bumper season that I think many of us would hope for. But anyway, I mean, these objects you can see here, with a bit of light pollution. Certainly the Orion Nebula you can see with under light polluted skies. It was my I always used to observe when I was in London, and you can't mistake the Pleiades as well. Sisters, as some people call it. If you have got darker skies, then why not take a trip up to Triangulum? And up here you've got a galaxy, which I don't think they've included in here, but it's about there. It's a face-on spiral called M33, and in dark skies it is a good binocular object. That it's about the same sort of area as the full moon, it appears as, through a pair of binoculars. So it's certainly worth taking a look at. So a few items there for you to take a look at, and yeah, I hope this has been informative for you, and I wish you clear skies, and please keep us informed in the Space Cadets group as to how you get on with your observing. Always interested to know. Thank you.